1.5 quadratic equations. All right, so let's solve a few more of these. Okay, so this right here, this is a quadratic because there's a 2 right there. If we want to solve it through the zero factor property, first step is to set it equal to 0. Already done. Next step is to factor. Because this has an 8 leading coefficient, it's going to make things a little more complicated. We need to multiply the 8 by the negative 7. So 8 times negative 7. And that gives you a negative 56. Next, we want to find two numbers that we can multiply together to give you a negative 56, that if you add together give you a positive 10. Because the middle term is positive, when you add them together, the stronger one must be positive and the weaker one must be negative. Opposite signs, with the stronger one being the positive, right? So negative 1 times positive 56 is negative 56. Negative 1 plus 56 is positive 55. That did not work. Negative 2 plus 28 gives you a positive 26. You can try 3. Doesn't look like it's going to work. How about a 4? Negative 4 plus 14 would give you a positive 10. So that worked. Okay, so we go over here. We write a couple of parentheses. Set it equal to 0. We put an x, which is the square root of the x. In the first place, because it ends in a negative, we know it's opposite signs, positive, negative. Because we've got a positive 14, we have to put that next to the positive. Because we've got a negative 4, we put that next to the negative. But we're not done. Again, we have an extra step at the beginning and an extra step at the end because we didn't have a one leading coefficient. It's made this more complicated. So what we do is, at this point, we're going to divide it by the leading coefficient, which is 8. So we divide that by 8, and we divide that by 8. And now we simplify. Now, if we couldn't simplify at this point, we would have pulled the 8s to the front. But in this case, we can simplify. So 14 divided by 8, we can divide both of those by 2. Divide both of those by 2. So what we would have ended up with is x plus 7/4. And that doesn't simplify anymore. So now we pull to the front. And then what we get is 4x plus 7. Over here, we say 4 divided by 8. We can simplify that. We can divide both these by 4. And what that gives me is x minus 1/2. Now, because we can't simplify that any further, we pull the 2 to the front. It gives me 2x minus 1. And this is still equal to 0. Now, at this point, because of the zero factor property, we know that if you multiply the first parenthesis by the second parenthesis, either the first parenthesis or the second parenthesis must be equal to 0. 0 times anything is 0. Anything times 0 is 0. So hopefully that works out. So we set it equal to 0 and we solve. Cancel, cancel. So we end up with 4x is equal to 7. Divide by 4, divide by 4, cancel, cancel. And we end up with one answer. I'll just put it straight into set notation here. Oops. 7/4, that's one of them. The other one we say 2x minus 1 is equal to 0, plus 1, cancel, cancel. 2x is equal to 1, divide by 2, divide by 2, cancel, cancel. And we end up with the other one equal to 1/2. Now, I did put this in ascending order, right? 1/2 is smaller than 7/4, but because I'm using set notation, doesn't matter. Don't worry about it. Okay, so that's the first one. Next one. Again, we don't have a one leading coefficient. Well, okay, let's not skip any steps. First step is set it equal to 0 if we're going to solve this using the zero factor property. So this is a quadratic. If I want to solve this through the zero factor property, first step, set it equal to 0. Check. It's already equal to 0. Next step, factor as much as you can, right? Now, in this case, because I only have 2 terms, I'm not factoring a trinomial. So let's see if I can factor anything out of this. Well, in fact, I can factor a 5 out of a 5 and a 10, and I can factor an x out of an x squared and an x. Okay. Now, at this point, I'm literally dividing these both by 5x. I normally don't write the steps, but that's actually what you're doing. You're going to put the leftover stuff within the parenthesis, right? So 5x squared divided by 5x is just x. 10 divided by 5 is a 2, and the x's just cancel out of there, leaving you x plus 2. Now, because of the zero factor property, we know that if 5x multiplied by x plus 2 is equal to 0, then either 5x is equal to 0 or x plus 2 is equal to 0. So we set them both equal to 0. Looks like we end up with x is equal to 0 for 1. We set the other one equal to 0. Minus 2, minus 2. And we end up with x is equal to negative 2. So it looks like we have a couple of options here, a 0 and a -2. Now again, I could have written this as -2 then 0 and had it in ascending order, but because it's set notation, it does not matter. When in doubt, though, just write it in ascending order. Put the smaller one on the left, larger one on the right. In this case, it does not matter because of the set notation. Later on, when we deal with interval notation, order does matter, and I'll point that out when we get there. All right, so we want to solve the quadratic equation by the square root property. And then let me give you a really simple example of this. If I say 8x squared is equal to 1, that means either x was equal to 1, right? Because 1 squared is equal to 1. But it could have also been that -1 squared is equal to 1. So in this case, you would have said, well, x must be either equal to plus or minus 1, right? Hopefully that makes sense, right? Either 1 times 1 is 1, or negative times 1, -1 times -1 is equal to 1. Either way, that work, right? So we're just doing the same thing, but a little more complicated looking. So first step is we're going to get the variable squared on one side by itself. So we're going to get rid of its coefficient. So we're trying to solve for x squared in this case. And we do that by undoing the multiplication of x squared by 2 by dividing by 2. And whatever we do to one side, we do to the other. Those cancel out, leaving me x squared is equal to 25. Then I try to take the square root of both sides. Now, technically, this symbol gives you the principal, or it gives you only the positive square roots. Okay, so technically this is the wrong symbol to use here. Normally that's only positive. I'm just using it so it doesn't seem like I'm using magic or something. But technically this is only positive, so just be aware of this incorrect notation. But I'm going to use it to just illustrate what it is I'm doing, and then get the plus and minus square root of 25. So again, this is technically true, but for illustrative purposes, I'm using it. Okay, so we end up with x is equal to plus or minus the square root of 25, square root of 25. But by the way, square roots are really just saying, I really cover this. This is really asking the question of what, right? What squared would give me a 25? And the answer to that would be, well, -5 squared would give me a 25, and 5 squared would give me a 25, right? That's what it's asking, right? So I know that this must be plus or minus 5. And again, technically, this normally deals with just the negative, so I'm kind of using it wrong, but that's okay. All right, so another one, again, first step is I want to solve for this x squared right here. But first I need to get this entire term with the x squared by itself, and I do that by undoing the addition of 9 by subtracting 9. And whatever I do to one side, I do to the other. So 24 minus 9 is going to give me a 15. So now at this point, I'm trying to finish solving or getting the x squared by itself, so I undo the multiplication of x squared by 5 by dividing by 5. Whatever I do to one side, I do to the other. Those cancel out. And that leaves me x squared is equal to 15 divided by 5, or 3. Next, I take the square root of both sides, and I'm trying to include all the square roots, not just the principal, or the positive ones, right? And it gives you plus or minus the square root of 3. And that's it. We just want to include the plus and the minus. Okay, let's try another one. Let's say, again, we want to get the entire term with the x squared by itself first, which means we undo the subtraction through adding 7. Whatever we do to one side, we do to the other. Cancel, cancel. We end up with 2x squared is equal to -50. So we undo the multiplication of x squared by 2 by dividing by 2. Whatever we do to one side, we do to the other, giving me x squared is equal to -25. Next, we take the square root of both sides. And that gives me plus or minus the square root of -25. Now, we haven't focused that much on the radicals yet, but I'll show you how to finish this one, but we'll go into more details about how dealing with imaginary numbers later. Basically what happens is you would simplify the square root. There's no real answer to this because there's no number that I can square to give you a -25, right? You might think it would be 5, but 5 squared is equal to positive 25, and you might have thought, oh, well, maybe it's the -5. Well, no, because -5 times -5 is actually equal to positive 25 as well. So there's no real number that's going to make this true. So what we would do is we're going to kind of factor the -1 out and give you a square root of -1 times positive 25. Then we break it apart, -1, square root of -1 times the square root of positive 25. Square root of -1 is equal to I, and that's times the square root of 25, which is just a 5, right? Which I times 5 is 5i. Okay. And I'll explain that slower when we get to it later on. But there's no real answer to this, no real number. But what it is plus or minus 5i. Okay, so let's try this one. Same kind of thing. This the same thing we did when we have an x squared by itself, is we do it to the entire parenthesis here. So we take a square root of both sides. So what we end up with is x minus 2. These basically kind of cancel each other out. There's an index of 2 there. We'll explain that again later. We'll explain that later in greater detail. But there is an understood 2 index, so those basically just cancel each other out. And what we end up with the square root of 25 is plus or minus 5, right? I skipped a step there, but the square root of 25 is 5, right? So it's actually plus or minus 5, right? So plus or minus the square root of 25, square root of 25 is 5, so we end up with plus or minus 5. So it's x minus 2 plus or minus 5. Let me say plus 2, cancel, say x is equal to 2 plus or minus 5. Now at this point we need to break it apart into the positive version, which is 2 plus 5, and we break it up into the negative version, which is, x is equal to 2 minus 5. And what this basically does is it allows us to simplify further. So 2 plus 5 is 7, and 2 minus 5 is negative 3. And at that point, we got it, right? Now you can always go back and check these answers. These are equations, so you can check your answers, which is not a bad idea. Okay, so let's move on to the next one. So we're going to determine the constant that would be added to the binomial so that it becomes a perfect square trinomial. So there is a pattern. Let's see. Let's do a kind of a simple one. Something like that. That's the pattern, right? So what we do is we're trying to figure out what we add here and what we add here to get it to fit a pattern like that. And what we do is we're going to take half of the middle term, or in this case, it's just the one that's the x, right? Basically the equivalent of the over here. So we're going to take half of that, divide by 2. And then what we're going to do is we are going to square it. You just want to memorize this. The proof's in the book for this if you're interested. So what we're going to do first is we're going to say 12 divided by 2 is 6. And 6 squared is 36. And then we're just going to add 36. Over here, we're going to do the same thing. We're going to say 9 divided by 2 squared. So we want to simplify with them, but in this case you can't. So now we're going to simply, I'll write this middle step here. We're going to square the top, and we're going to square the bottom. We'll go into that later. We get more into exponents. But basically you're going to say 9 times 9 is 81, and 2 times 2 is 4. Another way of kind of looking at this, if you don't really know these patterns, is saying 9 squared is equal, 9 halves squared is equal to 9 halves times 9 halves. Many times you can get around the exponent rules if you just write it without exponents and then just use other rules. Okay, so in this case you would say 9 times 9 over 2 times 2, and you'd also get an 81 over 4, right? So either way you end up with the same answer. And we'll go over the rules of exponents more later. Just trying to get you up to speed quickly at this point. And there we go. So x squared plus 9x plus 81 over 4. So with the 81 over 4, how to get it, right? And there you go.